那我们就开始哦。不好意思，耽搁了一点时间哦，因为要出那个 quiz 哦，那个真是。那个你有带那个电脑来吗 ？OK， 到时候我有传那个档案给你们嘛 ？OK， 好。Okay, so let's continue. Okay, so let D be a differential operation on P3. Let A and B respectively denote the matrices representation of D with respect to different bases. The first base is B1, x3, x2, x to the power of 1, 1, and B2 to be this thing. Okay, to find A, B transition matrix for B1 to B2 and B2 to B1, and verify the similarity of A and B. Okay, so basically, it wants you to make sure this is the case. Okay, and well, so we also need the basis transformation matrix, right? So basically, okay, this one, the first one, okay, I think we do like this differential like operation, like basis transformation already earlier. So the only thing we didn't do probably is this like linear transformation thing. So this, okay, the first one is like when it's B1, okay, base 1, okay, the 1 0 0 0. So we try to apply this transformation on the first base, which is x to the power of 3. So it's a differentiation, right? 微分嘛，就是 x 3次方微分就是 3x to the power of 2. So this, if you represent this by like the standard basis, is going to be 0 3 0 0, and then the next one, x squared. Okay, you do a differentiation, you get 2x, so it's 0 0 2 0. So the single x, if you do a differentiation, is 1, so it's 0 0 0 1. The last one is 1. I mean, if you differentiate 1, it's going to be 0. So it's like that. So the linear transformation for differentiation from base 2 to base 2 is going to be like this. B1 to B1. Okay, it's going to be 0 3 0 0 0 0 2 0 0 0 0 1 and 0 for the last column. Okay, so this is kind of obvious. The next one is a little bit complicated because you need to differentiate this one. You get like a 6 2x minus 1 square. So it's get because the 2x minus 1 square is like the second base. So it's 0 6 0 0. Okay, and then the 2x minus 1 square differentiation is 4 2x minus 1, or which happen to be like 2x minus 1 happen to be another base vector. So it's going to be 0 0 4 0. And then the where is the other one? Oh, this one. 2x minus 1 is you get 2. You differentiate this one, you get 2. So it's 0 0 0 2. And then the last one is 1, differentiate is 0. So, I mean, combine all these 4, you get this one. Okay, so we want to verify these two. What happened? You want to你有电池吗？这看起来是没电了。 you want to verify this matrix is similar to this matrix. Okay, one of them is A, one of them is B, basically in here. 你那个这个电池，哎，我们对，麻烦你。看一下，对，应该是没电了，因为刚明明就可以 work， 怎么突然就对，可以。好，谢谢。Okay, so obviously it also involved like this base transformation, basis transformation matrix. Okay, so we also need to do like this transformation. So the first one, the first base, okay, is x3. Okay, the first vector of the first base is x3. And if you want to represent this x3 by the second basis, it's going to be like, I think we have, yeah. The first one is probably easier. Okay, this one. The first one is 1000. It's going to be, 2x minus 1 cube. And if you, expand it, it's going to be like that. And if you want to use like the first basis, because like that's easy, right? It's x cube and x squared, x and 1, so it's going to be like that. Okay, and the second vector of the second base is 2x minus 1 squared. It's going to be like that. So if you use like the first base is going to be 0, 4, minus 4, 1, and the third one is 2x minus 1, so 0, 0, 2, 1. 2, negative 1, and then the last one is basically just the same vector. So if you represent like the transformation from second base to the first base, second basis to the first basis, it's going to look like this. And transformation from the first base to the second base is a little bit complicated. You either try to compute the inverse of this matrix, or you just do this. Okay, x3. You try to represent x3 by this different polynomials. Okay, so you get this one, and the x squared it can be represented by this. So it's going to be this, and then this one x can be represented by this. And the last one is the same. So if you do that, okay, the transition matrix from basis 1 to basis 2 is going to be like that, like this. And as I said, okay, if you multiply these two matrices, it's going to be an identity matrix. So nothing surprising here. Okay. And then what we are going to do is basically we want to just show this, right? So that's you can. This is once again you can see the flow chart comes out. Okay, this flow chart is so commonly used, but I would suggest you to remember or like take note of the first flow chart, not this one. Why? Because this one is the simplified version. This is from V to V. This is from V to V. The original one, the previous flow chart that we discussed is more general. It's from V to W. Remember? Okay. Obviously, that one covers this one, right? I mean, but this one, is a simplified version. So I would suggest you to remember the original version. Okay. So basically, yeah, I mean, you just do the verification of this, like that's it. Okay, I mean for this. Okay, so you already have the A, you already have the B, you already have the S, and the S inverse. So do your math. Of course, that's like a 4x4 matrix. It's like it takes time to do the multiplications, but Yeah. Yeah, that's, or MATLAB will help you, right? Okay, if you, I mean, we are in computer science, so if you are lazy, okay, you don't want to do the computation, I mean, you can always use like some software to help you to do these matrix multiplications. There are many different software package that will help you to do these computations. I don't know if you can ask, I mean, ChatGPT to do this, I mean, directly, or you can just use like the MATLAB or like a Mathematica, all those package that those packages should just have like built-in like a matrix multiplication. I think like Python can also do this easily, right? Yeah. So yeah, that's it. So that's it for this chapter. Okay, so yeah, I was hoping to finish like the chapter 4 and cover a lot more. Chapter 5. Okay. And chapter 5 is going to be very down to earth. Okay. When I say down to earth, I mean like there are some old material that you already know. Okay, from either high school or like the first year like calculus. Okay, I mean probably mostly from high school. Okay, and but there are also a lot of new material. Okay, but so but at least like compared to like the first like chapter 3, chapter 4, this chapter at least like those examples are much more, what should I say, like down to earth, friendly. Okay, so this chapter, what we care about the most is no longer like something that is more abstract. We are considering some things that are more concrete, such as like Rn space. Okay, so now you see like we can define length and the distance. Okay, for two vector in a n-dimensional space. Okay, so U is like this, V is like this, W is like this. Okay, there are vectors in Rn. Okay, and the C, D. Okay, represent scalars. Okay, so first definition, the length of V is, which we denote as like this, is defined as like V1 squared plus V2 squared blah, 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 plus Vn squared, and then square root of that. Okay, I think you learn this from junior high or high school, right? 是不是高中、国中还是高中学的？向量的长度还是高中？高中吧，对。So as I say, like this is like a more down to earth. I mean, much easier for you to consider or at least to understand. Okay, so it's called as magnitude or norm of a vector. Okay, so if this norm is 1, okay, then or like a length of that vector is 1, we call this vector univector. Okay, so to be honest, I mean you must have learned this from your high school. It's just like some of them is more like a review for you. Okay, 有一些是比较像是跟你回这个复习一下啦，或者说教你们说它这个英文的 notation 是什么东西。那 theorem, okay, CV the norm of CV equal to C, the absolute value of C times V, the norm of V. So this is theorem, okay? So yeah, it requires proof. But what? 是运动会吗？还是警报这样子？对，好吧。Anyway， 所以so we need to really like prove it, right? So, but the proof is so easy because if you say V is well, V1, V2, okay, V1, V2, Vn, and CV is going to be CV1, CV2, CVn. And then you can easily verify, the result, right? CV norm is going to be C absolute value of C times the norm of V. That's so easy, right? I mean, not much to talk about. So if V is a non-zero vector, then 1 over the norm of V, okay, times V is a unit vector and has the same direction as V. Okay, we'll talk about this direction thing later. Okay, but this one is a unit vector. It's very easy because how do we verify this is the case? You just need to do like the norm of but this one is just according to the first rule, you get this one out, right? Times norm of V. So this is obviously 1. So according to the definition, yeah, it's a unit vector, right? And then, okay, it has the same direction. Okay, geometrically speaking, it's easy to understand, okay, logically. But we will discuss, like, how to represent, the degree between two vectors. I mean, shortly. Okay, so right now, like, you just, try to understand this one as, like, geometrically. Okay, if you draw a vector, okay, if you divide that vector by a positive, because this 1 over the norm of V is a positive number. So divide this the vector by a positive number, it is still pointing to the same direction. Okay, so Euclidean distance between two vectors U and V is this one. Okay, this one, to be honest, this is more like a definition than a theorem, because we haven't defined the distance between two vectors. Okay, so yeah, I think this is more appropriate to be listed as a definition, okay, than the theorem, because yeah, I mean, how do we claim, like, if you want to prove something, you need to have a definition for that thing first. But since we haven't defined, like, the distance of two vectors, I mean, well, I don't know how we can, prove it. Okay, but anyway, okay, this should be easy to understand. Okay, I mean, basically, it's like, if this is U, this is V, then U minus V is what? U minus V. What is U minus V? Okay, it's let me see. This one, right? U minus V, right? Okay. So basically, like geometrically speaking, like assume this is the you draw these vectors on a geometric space. I mean, it should be easy to understand, like this thing, because I think like in high school, I mean, you see these things all the time, okay? And then, okay, let's the inner product, okay? So the dot or inner product of u and v is defined as u dot v, and given by u dot v equal to this one, okay? And if you represent u and v by column vectors, then u dot v is written as u transpose times v, because this is going to be, this one is dot or inner product of two vectors, but this one is going to be matrix multiplication. Okay, I just want you to understand, okay, linear algebra, okay, this course, okay, if somebody tell you, linear algebra, is algebra, okay, don't listen to that guy. Okay, that guy must come from mathematics department. Okay, so don't be cheated. Okay, for engineering department, okay, to be exact, for engineering department, linear algebra is about matrices. Okay. 就是我们在这一堂课讲的主要是矩阵的性质，矩阵的一些东西。就算是有一些东西你看起来不像矩阵，像刚刚我们讲那个 differentiation， 我们到最后把它表现出来还是矩阵，对不对？对不对？所以这一堂课最重要就是矩阵。如果有人跟你讲说啊，线性代数是代数的一部分，什么东西的，那都是数学系出身的，不要被荼毒哦。OK， 我自己以前被荼毒过，所以。这边有人数学系的吗？没有，有的话，对啊，跟你说声抱歉啊，因为我们资工系应该说工学院的线性代数跟数学系的线性代数是很不一样，性质很不一样的东西。OK， 我不是说数学系的线性代数不是线性代数，应该是说数学系它 emphasize 不一样。强调的东西不一样 ，OK， 我们这边强调的是操作 ，OK， 然后比较 down to earth 的，可以真的拿来用的。那数学系的线性代数强调的是证明 ，OK， 那如果你们对证明有兴趣，那其实这堂课，你说，孙老师教这门课好像一大堆证明，拍谁？我这个证明跟数学系的证明比起来，这个大概是可能不到他们的一半哦，不到他们的一半。我以前我在台大数学系学线性代数的时候，老师就说定义、lemma、theorem、proof 这样一路这样下来，没有跟你讲应用。任何的科目都是这样子，因为台大数学系就是至少我那个年代是纯数啊，全部都是，所以你学老半天你不知道在干嘛。后来我到美国念书的时候发觉说，老师上课的时候都先跟你讲说这个东西学来干嘛的，然后才教。我就觉得，我学到原来教书应该说，你要先让学生要有个 motivation， 学这个东西是在干嘛的，你再学才比较知道说为什么才学这个东西。那应该说纯数强调的是那个证明的技巧，然后那个东西跟我们工学院要强调的不一样。我们工学院强调的是解决问题跟 intuition。OK， 所以我不是说数学系现在不好，因为应该这样讲，我自己也是数学系出身的，所以我这样讲，我只能说他们不一样，好不好？不要被数学系的人骗了哦，就是他们要跟你讲你学的东西不是线性代数，不好意思，线性代数在我们的工学院定义就是 matrix manipulation， 所以这两个these two，one is inner product or like the dot product. Okay, the other one represent matrix multiplication. Okay, two matrix when they multiply together, they can become scalar. OK， 就是两个矩阵相乘，有可能变 scalar 嘛？当它变成它的 size 是1乘1的时候，对不对？那this is exactly the case. Okay, so conceptually, these two are very different, even though you know they are exactly the same, but conceptually they are different. Okay, then we have a bunch of theorems. Okay, so U inner product V equal to V inner product U. Okay, and this inner product and like matrix addition has like distributive law, and this is C times U inner product V is CU times V inner product V, and U inner product U equal to the square of norm of U, and U inner product U greater or equal to 0. Okay, the inner product U by itself is if it equal to 0 if and only if U is 0. Okay, so all this, I mean, supposedly you should prove by yourself, but I will skip those proof because you should have learned that all this in your high school. Okay, 如果你忘记了，你可以自己去写一下。这个你就是把每一个 vector 写成它的那个原始的形式嘛，这种就是这样子，然后你再操作一下，其实这不会太难啊。所以我就不写了哦，不写了。有困难来找我，好不好？我没有说你们一定都没有困难，但是讲老实话，有困难会进来中央，那代表你其实天纵英才，那也不错。那我们也可以讨论 ，OK。好 ，Anyway， then we have some important theorem, okay, which you have learned from high school, okay, or like even junior high, okay. U inner product V, the absolute value of that small or equal to U the norm U times norm V. Okay, so in other words, we have this. This is the Cauchy-Schwarz inequality. I mean, but 我想好像在高中的时候，我们这叫柯西不等式，是不是？是不是？中文就因为那个这个Cauchy这个中文翻译可能就叫柯西啦，柯西不等式。如果其实翻成中文，其实比较像柯基啊。对，但是讲柯基不等式，可能大家会想要小狗去了。对，但是没有关系，反正就是这个东西这个东西证明哦，这其实这个其实应该是很容易证啊。那要证吗？我也不知道，因为我本来是觉得说应该要证，但是后来我觉得说，因为我觉得，因为我花了很多时间在搞那个 quiz 哦，因为助教跟我讲没有，就我昨天又没准备，那搞到浪费了大概是20分钟，所以我想这些简单的东西，我就让你们自己去搞了，好不好？因为这其实是高中的东西啊，柯西不等式的证明，难道你们高中没学过吗？应该有吧，对不对？有吧 ？OK， 当然有很多种证明方法哦，有很多种证明方法，你可以用代数就直接去证，你也可以用那个几何的方法去做这个东西，都可以。OK， 几何方法就很简单嘛，就是 inner product 会等于，就是 U inner product V 会等于 U 的那个 norm times V 的 norm times cosine theta， 对不对？这个大家都知道，对不对？那因为 cosine theta， 所以它的值从都要负1到正1嘛。那你取绝对值，那就是它会等于的时候，就是你 cosine theta 等于1嘛，对不对？那就是说 cosine theta 等于1是什么时候？就是他们那个嘛，就是平行的时候嘛之类的。这个东西就应该你用很多的方法证。那我就是随便用口述的方法随便讲一个，你们自己去看啊。然后再来，我把这一页讲完，我们就下课，好不好？不下课，就一个 take a break，OK， 不好意思。然后再来 ，the angle between two non-zero vectors u and v is given by this one. So this is definition, okay? So this definition from here you can get, as I say, the Cauchy inequality, okay, and also you can use this to show that two what should I say, like two vectors, their degree between these two vectors. Okay, so this is the definition. Okay, and two vector u and v are orthogonal if u dot v equal to 0. In other words, okay, if u dot v, the cosine theta is 0, means like it's a 90 degree, right? 90 degree. Okay, 如果你不知道这个字哦，你要记得这个 orthogonal， OK， 就是垂直的意思。OK， orthogonal。好，那讲到这边，我们先休息一下哦。我先把这个下页把它放出来，你们就看到说啊，好怀念高中的时候啊，三角不等式跟这个什么 Pythagorean theorem， 这是什么？毕氏定理嘛。因为高中你们其实应该国中吧？对，但是你们讲毕氏定理，你们以为说是跟那个小毕的故事有关系，那不是哦。那它的那个名字因为太复杂，叫 Pythagorean 哦，那个中文翻译会比较难翻，所以他们就讲说毕氏定理叫 Py 嘛。所以说那个，所以你们如果将来学，你们会 Python， 将来就最近跟人家讲说，我会那个毕氏程式设计这样，没有开玩笑，那个就是我们好，我们先休息一下，我们回来再。